Hi, everybody. I'm going to take you through lesson 4 today, which is a continuation of yesterday's lesson on alkanes. Yesterday, we learned what alkanes were. We learned how to name them. There's a systematic way of naming them. And today, we're going to focus on drawing those structures. Now, the good news is that is a lot easier to draw them. But we're also going to incorporate another concept, which is called structural isomers. So as usual, you're going to click on what do I do? And you're going to click on the summary note that you will fill in. Okay, so here is what the summary note looks like when you click on it. And we're going to fill it in by using, if I go back, that main resource note. So click on your main resource note. It's going to take you to the note that we started yesterday. This note is fairly long, so we're going to be keep going back to it. And we're going to scroll down after the instructions on how to name our alkane molecules. So again, just a refresher, we find the longest carbon chain. If there's branches, we start numbering from the end closest to the branch. We identify the branch name, 2 carbons. The prefix for 2 is eth, so this is called an ethyl. It's sitting on carbon 3 of a hexane molecule. So this is a 3-ethyl hexane. And again, we've gone through the instructions here, and you have a worksheet that you've been working on how to name them. On that worksheet, there are some spaces where you have to draw them. And now you'll be able to do that after we go over our lesson. Okay, so lesson 3 ends here. We're going to start lesson 4 here where it says drawing condensed structural formulas. So it's pretty easy actually to draw organic molecules once you understand the language. Okay, so you're all aware of what the prefixes mean. You're now aware how something like this right here, if we look, actually, let me full screen this for you. What happened? Oh, sorry. Scrolling back. Here we are. My apologies. Okay, so if we were looking at something like 2,3-dimethylbutane, if I say to you, draw this structure, you now have some sense about, what this even means. Last week, you had no idea what a butane was. You had no idea what a methyl was. Why are there 2s? Why are there 3s? So when we're looking at a structure like this and we are asked to draw it, you have to isolate the parent. Okay, so there's the parent structure right there, and that is a butane. And you should know that but stands for 4 carbons. So what we do is we draw out 4 carbons in a row. This is going to be our parent, and this is going to be the longest chain. Then if we click on step 2, step 2 is going to take us where we know that butane is our longest chain. Here it is. And we know that on carbon 2 and on carbon 3, we have 2 methyl groups. Okay, well, what does meth mean? Well, we know from our chart yesterday that that refers to 1 carbon. So here they are. They're putting 1 carbon as a branch on carbons 2 and carbons 3. Now, they have 1 branch going down and they have another branch going up. It doesn't matter. Okay, you could have them both going up. You could have them both going down. You could have this one going up, the other one going down. Oftentimes, we put them on opposite sides only because when all the branches are on the same side, it starts to get messy looking. Okay, so that's all. And sometimes it kind of gets cluttered. So often we'll put them on opposite sides. Okay, that's the only reason that we do that. Step 3, what do? Well, now we fill in all of our hydrogens, okay? Now they're doing condensed. Sometimes I'll put little ticks. You'll notice that on my answer sheet that I'll often put just a little tick around a hydrogen, which represents a bond, around a carbon, which represents a bond to a hydrogen. And I'll do that with rough work. But then what you're supposed to do is you're supposed to show that, remember that every carbon will form 4 bonds. So this carbon is bonded to the carbon next door. That's 1 bond taken up. And so he has to have a total of 4. The other 3 bonding sites will be to hydrogens. So we just condense that down that way. This carbon in the middle is bonded to a carbon on the other side, a carbon on the other side, carbon below, that's 3. He has to bond to 4 atoms. So that means that the 4th atom would be a hydrogen. And that's why you see 1 hydrogen listed there. So this is all that we're doing is we're filling in the hydrogen atoms as we go through. And then lastly, step 4 says just to recheck your work and make sure you know what's going on. So it's actually, again, quite a bit easier to draw these molecules once you have an understanding of what the prefixes mean and the way that we represent organic molecules. So here are some examples that we want you to try. And if you go to the summary note, they are listed there and you can give them a try. What I would suggest, and I think I've written that there, is I would draw those on paper. And then you can check your answer here. Try not to check your answer initially, like try to draw it out. And then take a picture of the molecule and then insert it into your summary note if that's helpful to you. Okay, so again, some of you will be using the summary notes solely online. Some of you might be printing them off. If you're printing them off, then just draw your structure on the paper. But this is a good way if you take a photo of your work and then insert it in the Google Doc just to have everything there. Now it says take a break, but we're not going to. Okay, we're going to keep going. And we're going to just talk also about structural isomers. Okay, so I have some questions for you in the summary note, but I just want to go over what a structural isomer is. So a structural isomer is something that has the same chemical formula. So if I look at these 2 isomers, these carbons add up to 4. So I have 1 here, 2, 3, 4. And if I look next door, I have 1, 2, 3, and 4. Okay, so I have 4 carbons. If I count up all my hydrogens, I am going to start over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I go to the second molecule, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 4 carbons and I have 10 hydrogens in both of these molecules. But when I look at those molecules, they look different. And this is what a structural isomer is. It is something that has, right here, molecules that have the same molecular formula. Okay, so molecular chemical formula, but different structures. And this is really important right here, folks. You can tell if 2 structures are isomers if they have the same molecular formula, but they are named differently. Okay, so if I was to name this molecule, this is a straight chain alkane, okay, all single bonds, 4 carbons in a row. Okay, what's the prefix for 4? Prefix for 4 is bute. They're alkanes, so this is called butane, and I have no branches there, so that's the name of it. If I look at the next molecule, I have 3 carbons in a row, which would be my longest chain, and I have 1 branch attached. So my longest chain is no longer a butane, as it was next door, it's a propane. And then on carbon 2, I have a methyl group. So this is 2-methylpropane. And those are 2 different names, but the chemical formulas or molecular formulas are exactly the same for each of them. Okay. So this is what isomers are. And this is an important thing to know because in organic chemistry, there's, isomers apply to every type of family that we have. And it is important for you to know what an isomer is and also try to come up with the different isomers. Okay, so here's an example. Here is C5H12. And they are showing you the 3 different isomers. And if I asked you to draw the isomers for C5H12, I'll give you a couple pieces of advice here as to how to do that. The easiest way to draw the isomers is to start with the carbons all in a longest chain. Okay, so I would put 5 carbons in a row, just like this, and I would place my hydrogens around to make sure I have 12. If I come up short, okay, so let's say I was placing my hydrogens around and I didn't have enough. Say I had 10 and I'm like, oh, I don't have enough, hydrogens to fill up all the carbons. Then you have a double bond somewhere or a triple bond somewhere. Okay, so be aware of that. Once you have your longest chain of carbons in a row and you name it, Then to come up with other isomers, my advice to you is just to remove one of those carbons and then deal with 4 carbons in a row. Okay, so here's 4 carbons in a row. And then where could you place that carbon to get a different molecule? Well, you're not going to place that carbon on the end here. Okay, because if you place that carbon on the end, that would still be 5 carbons in a row. So you could place the carbon over here, 1 carbon in off the parent. And then if you numbered this, we'd start numbering on the side, 1, 2, 3, 4, and we have 2-methylbutane. So could you move this little carbon group anywhere else on this molecule? Some of you are going to say, yeah, you could move it right here to carbon 3, but you can't because carbon 3 doesn't really exist. Remember, if the branch was right here, we would start numbering from this side. So it actually would be exactly the same. It would be 2-methylbutane. So this is the only option you have there. So once you exhaust your possibilities with 4 carbons in a row, now take off an extra carbon, okay, and go down to 3 carbons in a row as your longest parent chain. And then you have 2 carbons left over. And then you'll see there that we have to place them above and below in the middle of the molecule. Again, you can't put branches on the end because when you put branches on the end, you extend the longest chain. So this is a little bit of background there on isomers. And here are some examples that we want you to try. And I give you an extra 1 or 2 on the summary note as well. And then we're going to stop here. Okay, so you'll see that alkenes is listed next. I'll come in and I'll edit this to say that lesson 4 stops here. And we're going to deal with alkenes. Actually, I guess we're going to be dealing with alkenes next week. Okay, we have a little task to do tomorrow on hydrocarbons. So give these a try. And as usual, be in touch if you have any questions and if you need any help at all.